Okay, sounds good. Okay, thank you for this invitation to this AI Ocean Forum. So my name is Nicolas Longepe. I'm with the European Space Agency, and indeed, this talk will be what we call EVE, so the Earth Vector Experts, which is an open agentic platform for intelligence. Next, please. So what we aim to do is that, okay, the literature, all the knowledge on Earth observation and Earth science is very much fragmented. And as a user, depending on their level, I mean, practitioner, but also decision makers, it's very hard to have, well, let's say, sounded and trusted information through all this vast amount of scientific knowledge that we have. And obviously LLM agent could be a good way to interact with these informations, and especially in the framework of what has been presented before, this retrieval augmented, whereby you can have LLM that reason over a set of trusted and citable and reference domain specific sources. Next, please. So here with this project, uh, next, we wanted to, yes, please. We wanted to really democratize Earth observation knowledge, accelerate science innovation so that anyone can be faster in the way they review literature, they do synthesis and so on, and at the end, provide a tool for decision intelligence. Just this version that we'll present in the coming minutes, it's a pure, for now, textual information and documentation, let's say, tool. Uh, but definitely on our side, the idea is really to use that tool, which is now trusted in Earth observation, to make it, let's say, reason over as well Earth observation data, because as it was presented by Isemdo and we colleagues before, at ESA as well, we have tons of information, Earth observation imagery is coming from satellites, and we want as well this agent, this LLM, to reason over not only textual information, but also Earth observation imagery. Next, please. So the way we did it for this first version is actually we collaborated with some partners in Europe. Next, please. Yes, we collaborate with different partners in Europe to make this happen. So we work with Spy School, which is a startup in nearby Rome. We work as well with Imperative Space and also Mistral, because in order to fine-tune a model is very specific and could be very hard. So what we did, well, this is like the workflow of all the action that we carried out. So we fine-tuned our model on Earth observation. So what we did is that we created Earth observation domain data. So we scrapped Earth observation knowledge coming from different books, publication, and so on. I'll come back on the compliancy a bit later. We created some synthetic information from that. And what we did as well is to combine this specialized information with general domain, because if you want to fine tune a model, then you don't want to forget, let's say, general capabilities, let's say. And this is why merging this replay data with the synthetic generation information was very detrimental. So we did that together with Mistral. And at the end, you align, I mean, there's some specific, let's say, phases here. Once you have this if instruct model, then as a user, you query your prompt to this model. And the other very important thing is that we connect to RAG database, which has been presented before, with also protocol, which is called MCP. And through this external database, you provide some additional context to your model so that the output is always grounded with some actual and factual information coming from different trusted sources. Next, please. So what we did indeed is that we collected a bunch of Earth observation and Earth science text. So here you see it's 2.8 billion tokens, and then we generated about 10 billion tokens. So just for you to appreciate, this 10 billion token is about, let's say, 7 to 8 million pages of documentation that we ingested into the pre-training or continuous pre-training, let's say. What we did is that we wanted as well to benchmark our model. So we created actually through the expert that we hired to create our own benchmark data set for observation and science. So here you see we created different benchmarks for multiple question and answer with hallucination as well, detections, open-ended question and answer, and so on and so forth. So we created about 5 to 6 thousand samples, all manually created with experts in the field or people knowledgeable in the field. Next, please. Within the RAG system, so this which is used at inference, we have a set of documents which are then available. So as I said before, we mined different information from different sources. Could be MDPI, Copernicus Journal. We got as well an agreement with Wiley, the publisher, to get access to their publication. So all this publication is all about Earth observation, science. That include as well oceanography, maritimes, and everything. We as well included a special collection with all these are technical notes, at least the one which are, let's say, publicly available. So we did that as well for the pre-training data set, all in full compliance with all the rules, also attribution with CBI. We look at all the license. We will disseminate as well all this data set that we prepared, and we're very cautious in the way we attribute it, look at the license for each and single documentations that we scrapped. Next, please. We implemented as well next, if you go next to the hallucination detections, please. So we implemented, an hallucination detection scheme because, again, even though you have the RAG system, so it's always somehow trusted. You have always some kind of context which is trusted, but we wanted to reinforce on the confidence that the user may have in using the tool. So we implemented some kind of hallucination detection scheme. I will not enter into the details here, but we are using the LLM to judge if it's good or not, and then reprompt actually that with new requests to the RAG as well. And this is quite powerful. And sometimes indeed, from the first, let's say, loop, you detect some hallucination natively. Next, please. So of course we did this massive continuous pre-training, fine-tuning together with Mistral and PySchool as a partner, and at the end we did a full benchmark of our model. So, and this is the one on the left, which is called even stripped on the different benchmark data set that we created, and generally speaking, I mean, you have a true added value when you fine-tune your model over specialized corpus of informations, and here we are. Somehow beating other standards model which is of similar size. I didn't mention here, but we are using as a backbone Mistral 3.2, which is 32 billion, 24 billion tokens, sorry, which is kind of intermediate size. Of course, it has to be a trade-off between performance, but also cost in running the inference. So here, this kind of model is kind of intermediate size. And if we compare to other models, I mean, we are on par or even better than them. And we also compare with like super large model, and we are almost on par as well, but with an economic cost which is way lower. So which is very appealing. Next, please. We wanted as well to look at how we preserve the general capabilities of the model. So here you have the backbone model, which is the small 3.2, and we compare with the EVE, I mean, the new model that we fine-tune. And on basic functioning of LLM like math, reasoning, coding, tool callings, because indeed we want to be agentic oriented. We preserve the good capabilities of the backbone model, but also improve them. And we were pretty surprised with Mistral that even though it's trained on observation information, you gain some other knowledge that could be useful for math, reasoning, and so on and so forth. Next, please. So this EVE actually is coming with the user interface, which is more or less like any kind of chatbot, even though chatbot is a bit, it's a bit negative, let's say, but it's you can set up some parameters for the LLM. You can look at the different sources which are then cited because we have this RAG through the MCP protocol. We have this hallucination detector. Next, please. And actually, this model was deployed during 6 months. We had a pilot that's run from November last year to March, April this year. And so through this pilot phase, I mean, we got many feedback from all the users, the beta users, and we'll improve the next version. Next, please. So in the end, this is, please, you can click again to the next slide, the conclusion, at least the first conclusion. Yes. So we specialize this 24B LLM from Mistral to something which is very specialized in the subscription neuroscience, while still maintaining the good performance of the backbone models. The data set that we created, as well as the benchmark, will be all released with full compliancy with EU rules, and will provide as well. While the rack system, all the backend, the front end, everything will be open source. We plan to release the tool with web and APIs actually in the coming maybe 1 or 2 months, and it will be fully available to the community to play with. Next, please. And obviously, the next direction for us is around, well, of course, opening the tools to the community. Next. If, yeah, if you can click again, please. Uh, thanks. And also to make sure that the we can interact with not only text but also images, which is of course very important for observation data. And indeed, the idea is to be community driven with the capability to host any tools, any geospatial analytics from the community, and be really like a community platform for all of us. Next, please. So thanks a lot. I think this is the end of this presentation. If you can click again, there's the QR code if you'd like to access all the resources, also to register for the launch, which will happen, let's say, in 1 or 2 months now. And if you want to follow us on Twitter, LinkedIn, or whatsoever. Thanks a lot.
Thank you very much, Nicolas. Thank you. It seems like it was a pretty popular usage of the chatbot. Do I understand that correctly? That you talked about over 300 users, over 500 conversations. Is that something that can be absorbed pretty easily? Just out of curiosity, imagine it's exponential. Is that what you anticipate?
Yeah, I mean, for now, this pilot phase was very like confined into some specific user. I mean, mostly internal ESA colleagues, but also a few colleagues that we contacted through the community. The idea is really to scale and to, let's say, reach all the EO community which have some interest in observation and science. So the idea is really to scale publicly and be available for all
Scale publicly.
scientists, but also public. Public and anyone in the population somehow.
Right. There's been a good focus this whole morning on the user uptake and the user experience with all of these tools. So thank you very much for also focusing on that. Let's thank Nicolas Longepe and